Hi, for the first question, for the first part of this question, it asks what the input area is of the input piston. So I have a crude diagram of what is happening in the question with the information we were given. This is our D, let me fix that, this is our D2, so it's going to be D1. And we want to know what our area of the input is. So for this, we can use the relationship that P equals F over A, and this is constant, so that means, that F1 A1 equals F2 A2. And that means that 380 over A1, which is our unknown, equals 960 kilograms per unit times gravity, which is 9.8 meters per second squared, all over area 2, which is going to be pi r squared. So pi 0.18. We want to make sure our units are in meters, divided by 2 squared. And we can plug this into our calculator, and we're going to get that A1 is equal to 2.54 times 10 to the negative 2 meters, or 2.54 centimeters. For part B of this question, we are asked the work done when lifting the car. So for this, we're going to use the equation that work equals force times distance. And we know that our force is 960 kilograms times 9.8 meters per second squared. And that's going to be multiplied by 0.42 meters, because we want to keep our units the same, so we've converted centimeters to meters. And we plug this into our calculator, and we'll get 39.51.4 joules. Let's box these in really quick. So this is our answer for A. This is our answer for B. Now for part C of this question, we are asked if the input piston moves 13 centimeters in each stroke, how high does the car move up for each stroke? For this one, we're going to remember that the work is constant, or is conserved. So we know that 3951.4 joules is going to equal 380, which, if we scroll up here, is our input force times the distance. So we plug that into our calculator, and we get 10.4 meters. That means that 10.4 meters is how much that the input has traveled for to do this amount of work. So we can take this and we can divide it by 13 centimeters. So divided by 0.13 meters. And that's going to give us 80. And that's the number of strokes that we are using. So what we can do now is take our original distance that we traveled on the output side, so this 42 centimeters, and we can do 0.42 meters divided by 80, and that will give us 5.25 times 10 to the negative 3 meters. And that's how much the output traveled for each. The output traveled for each stroke. And if you want to simplify that, it's 5.25 millimeters. Just pop this in. For part D, it actually asks us, wrong color. For part D, it actually asks us how many strokes are required to make it go up the 42 centimeters, which we already solved for. So that's going to be 80 strokes. We got that from up here. Go ahead and box that in. And then for part E, wrong color again. For part E, we need to show that energy is conserved. So for E, we're doing we're showing energy conservation. So work is literally the transfer of energy. So for this, we're just going to reiterate that work in equals work out. You'll recall up here that we calculated work as being 3,951.4 joules. So both of these should equal 3,951.4 joules. And our work in is going to be the 380 newtons times the 10.4 meters that we found here. So 380 times 10.4 meters. And we calculate that and we get 3,952 joules. With rounding, it makes sense that it's slightly off, but this is the same thing. So this is our work in. Our work out is, again, up here. It's the 960 kilograms times 9.8 meters per second. Meters per second squared times the 42 centimeters, so 0.42 meters. And this is literally the equation we used to calculate work initially. So it is 39.51. 3,951.4 joules.